Alright, we're going to look at some solutions for problem 823, which is where we're drawing E2 and E1 mechanisms for a set of reactants. The first reactant we're looking at is 2-bromopropane. So I'm going to start by drawing out 2-bromopropane. Prop means 3 carbons. Bromine on this one. Here. That's number 2. I'm going to draw out the other hydrogens here. The reason I'm trying to draw in all the hydrogens today, whereas sometimes we just ignore them, is in E1 and E2 reactions, we have to take away a hydrogen in order for a double bond to form. So this is 2-bromopropane. And I'm going to react this with, in this case, potassium hydroxide, which is a metal ion, and the hydroxide ion here. And they will ask us to draw an E2 and E1 reaction. I'm going to start with the E2 reaction. And in the E2 reaction, two things happen at once. My nucleophile, my base, is drawn in towards a positive hydrogen. Remember, hydrogen does a poor job of holding on to electrons, so he's going to be slightly positive. I picked this hydrogen because it was close, and this carbon at either end are identical. At the same time this happens, my more electronegative carbon is going to draw that pair of electrons down towards it. And bromine, being highly electronegative, would draw this pair of electrons up towards it. So we get a transition state for one moment where I have on the left a CH3, it's not doing anything fancy. We have our carbon here with a bromine on it that is preparing to take away electrons. We have a hydrogen here. Over here, I have carbon, hydrogen, hydrogen, and a OH group attached to that hydrogen. And again, I can show in this transition state where all of my electrons will be drawn. This pair of electrons will be drawn here, and that bromine will draw the electrons up and away. So that my final product after this transition state is complete in this E2 reaction will be, again, H3C on the left, doing nothing fancy, carbon, and has a hydrogen on it still. And now I have a double bond connected to this hydrogen, hydrogen, and hydrogen. Things that have left, I now have the possibility of an HOH or an H2O, water, floating around. My bromide is loose, off doing whatever bromides do when allowed to run free. He could be drawn to the potassium or just drawn towards the water somewhere else. Truthfully, he doesn't have a carbon, so we as organic chemists don't care so much about him right now. All elimination reactions, like this E2 reaction, have a leaving group that goes away, have a nucleophile and base that steal a hydrogen and leave us with a double bond. So that's how we have an E2 reaction like this. An E1 reaction can be made as well using the same materials, since we're not really differentiating the conditions for those reactions right now. All I have to do for an E1 reaction is start with the same materials. Change my pen back to something that's visible. I have a CH3 over here. Connected to my carbon that had bromine on it. And its hydrogen hanging out here. And carbon H's. There's nothing different about the carbon on the left and the one on the right. I just got lazy. I have H3 over there. As long as next to my alpha carbon I have at least a beta with a hydrogen, this is possible. Again, I'm reacting this with the potassium hydroxide. It's a metal, so it falls off and leaves us with a strong base nucleophile hydroxide. Now in an E1 reaction, like we're trying to show in the next part, bromine is capable of just taking that pair of electrons and leaving. And it leaves us with a carbocation again. CH3 connected to carbon. This hydrogen is left. Now has a positive charge because it's lost a pair of electrons. Carbon. Its hydrogen's over here, my beta carbon over to the right. And in this scenario, the hydroxide, instead of being drawn towards the positive carbocation like it would in a substitution reaction, it manages to collide with and share electrons with this hydrogen. That allows this pair of electrons to get drawn down here and leave us with our typical double bond that we finish all of our elimination reactions with. The difference between this E1 mechanism and the E2 mechanism we looked at earlier is in this E1 mechanism, the leaving group goes and leaves us for a brief moment with a carbocation. And it's that moment of rate where there's just one step happening at a time before the hydroxide comes in that separates E1 from E2. I hope that helps with problem 823 from last night's homework.